Everything you have ever seen with your own eyes, every star, every planet, every galaxy, accounts for only about 5% of everything that exists. The remaining 95% is split between two invisible components, roughly 27% dark matter and nearly 70% dark energy. Both dark matter and dark energy were never directly observed. Scientists inferred their existence purely from the way they shape everything we can see. Astronomers cannot observe dark matter directly, because unlike ordinary matter, it does not appear to emit, absorb, or reflect any form of light. Instead, they detect its presence only indirectly, through the gravitational pull it exerts on the stars, galaxies, and light we can actually see. In 1933, Swiss astronomer Fritz Zwicky studied the Coma cluster, a group of over 1,000 galaxies bound together by gravity. He measured how fast individual galaxies were moving within the cluster, and found they were racing far too quickly for the cluster's visible mass to hold them together. Zwicky calculated that the visible matter alone was nowhere near enough to generate the gravity required, and gave the missing mass a name: dark matter. 4 decades later, astronomer Vera Rubin, working with Kent Ford, measured the orbital speeds of stars within spiral galaxies like Andromeda. By Newtonian physics, stars far from a galaxy's center should orbit more slowly, the same way outer planets orbit the Sun more slowly than Mercury. Instead, Rubin found the outer stars moving just as fast as the inner ones, producing what astronomers now call a flat rotation curve. If only visible matter were present, a galaxy's rotation curve should decline steadily toward its outer edge, exactly as gravity from a central mass predicts. The observed flat curves suggest something else entirely: substantially more mass surrounding every galaxy than any telescope has ever been able to detect. Current cosmological models suggest every large galaxy sits inside an extended halo of dark matter, far larger than its visible disk of stars. This halo may stretch hundreds of thousands of light-years beyond the last visible star, invisible yet gravitationally dominant over everything the galaxy contains. One of the strongest pieces of evidence comes from gravitational lensing. Einstein's general theory of relativity predicts that massive objects bend the fabric of spacetime itself. As light from distant galaxies passes through this bent spacetime, its path curves, stretching background galaxies into glowing arcs and rings. The 2006 Bullet Cluster observation used exactly this effect to map dark matter directly, separate from the hot visible gas at its center. By carefully measuring how much these background galaxies distort, astronomers can reconstruct the total mass responsible, whether or not it emits any light. These lensing maps consistently reveal far more mass hidden throughout the universe than every visible star and galaxy combined could ever account for. Large sky surveys reveal that galaxies are not scattered randomly. They are strung along an immense cosmic web of filaments stretching across billions of light-years. Computer simulations show this web forming first in dark matter, its gravity pulling ordinary gas and dust along the same invisible filaments. Visible galaxies then collect precisely where the simulated dark matter is predicted to be densest, matching observation to model with remarkable consistency. Despite decades of dedicated research, no experiment on Earth has ever conclusively detected an actual dark matter particle passing through a detector. Detectors like Xenon and Lux Zeppelin sit deep underground in old mines, shielded from cosmic rays, waiting for a single rare collision that has yet to come. Physicists have proposed several candidate particles beyond the standard model. Weakly interacting massive particles, or WIMPs, were once the leading suspect. Others favor axions, ultralight particles first proposed to solve an unrelated puzzle in particle physics, or sterile neutrinos. Every one of these candidates remains unconfirmed. Not a single dark matter particle has ever been directly observed in any laboratory on Earth. Whether dark matter turns out to be an undiscovered particle, evidence of entirely new physics, or something no one has yet imagined, solving this single mystery would fundamentally change how humanity understands the universe, and the 95% of it we still cannot see.